Okay, let's continue. So let's continue. So our main objective is to discuss about polynomial functions. Okay? So the general form of a polynomial function is f of x is equal to a sub n multiplied by x sub n plus a sub n minus 1 x raised to n minus 1 plus a sub n minus 2 multiplied by x raised to n minus 2 plus up to a sub 0. So when we say a sub 0, you're referring to a constant term. Okay? So our main objective for today is to discuss about how do we determine the domain and the range of a polynomial function. Okay? How do we determine the domain and range of a polynomial function? So we have domain and range of a polynomial function. Polynomial function. So to determine the domain and range of a polynomial function, we need to consider the following conditions. So the first one is the degree. When we say degree, you are referring to the highest exponent. Okay? Degree, you are referring to the highest exponent. Next is the leading coefficient. The leading coefficient. And then next will be domain, range, and then end behavior. Okay? Miss, what do you mean by end behavior? When we say end behavior, you are referring to the starting point and then the ending point of your graph. Okay? So when we say end behavior, you're referring to the starting point up to the ending point of your graph. Okay? So we need to follow these conditions in determining the domain and range of a polynomial function. Okay? I will give you example later. So if the degree is odd, what do you mean by odd? What is odd? What is odd? You're referring to what? Okay, a number divisible by 2. So what are those numbers? What are those numbers? What are, okay, 1, 3, 5, 7, and so on. So those are odd numbers. So if the degree is odd, so again, when we say degree, you are referring to the highest exponent of a polynomial function. Okay? The highest exponent of a polynomial function. So if the degree is odd, and then the leading coefficient is positive, okay, so their domain is from negative infinity to positive infinity. Okay? Next, if the degree is odd, and the leading coefficient is negative, still the domain is from negative infinity to positive infinity. Meaning, all the values of x, okay, are real numbers. Okay? The elements of x are real numbers, set of real numbers. Okay? What about even? If the degree is even, again when we say degree, you're referring to the highest exponent. So if the degree is even, and then the leading coefficient is positive, so the domain is from negative to positive infinity. Meaning, again, x are the elements of real numbers. Okay? It's even, and then this time, it's negative. Okay? The leading coefficient is negative. So the domain still from negative infinity to positive infinity. In short, okay, the domain of a polynomial function is always set of real numbers. Okay? Set of real numbers. Meaning, from negative infinity to positive infinity. Now, what about the range? Okay? So to determine the range, we need to use the end behavior. So what is end behavior, miss? When we say end behavior, okay, when we say end behavior, we're referring to the starting point, okay, and then the ending point of your graph. Starting point and ending point of your graph. Okay? So what is the end behavior if the degree is odd and the leading coefficient is positive? Okay? So what is the end behavior if the degree of a polynomial function is odd and then the leading coefficient is positive? So the end behavior Okay, it's like this. So it will start in quadrant 3 and it will end in first quadrant. Okay, the graph will start in the third quadrant and it will end on the first quadrant. So like this. So that is the graph. If the degree is odd and then the leading coefficient is positive. Now, based on the graph, how do we determine the range based on the graph? What have you noticed? Based on this graph, how do we determine the range? If you have noticed, in determining the range, if the graph is like this, you can extend it. You can extend the highest value going to positive infinity, and you can extend also the lowest value of y into negative infinity. So therefore, the range will be negative infinity to positive infinity. Okay? If the graph is like this. Okay? So how do you come up with this graph? You can have this graph if and only if your degree is odd and the leading coefficient is positive. Okay? Now next, what about odd negative? Okay? Odd negative. So it's odd and then negative. So what is the leading coefficient? Okay? So odd and then the leading coefficient is negative, what will be the range? So to determine the range, again, we need to look for the end behavior. Miss, what is end behavior once again? So when we say end behavior, you're referring to the starting point and then the ending point of the graph. Okay? So if it is odd, negative, so the starting point will be second quadrant and then the ending point will be on the fourth quadrant. Okay? Starting point, second quadrant, ending point will be on the fourth quadrant. So like this. So like that. Okay? So again, if the degree is odd and then the leading coefficient is negative, so the end behavior will be from the second quadrant, that's the starting point, going to the fourth quadrant. Okay? So this is the end behavior. Now, in this particular graph, you can determine the range. So how can we determine the range? So pwede mo extend yung y value from negative, and then you can extend also the y value to the positive points. So therefore, the range is from negative infinity to positive infinity. Okay? So that is for odd degree. Odd degree, if the degree is odd and then the leading coefficient is positive, so the domain and range are both set of real numbers. So what is the end behavior? The starting and ending point. So the end behavior of a polynomial function with a degree which is odd from the second quadrant, start with the second quadrant, going to the first quadrant. Okay? Left falls down, right up. Okay? Left down, right up. Or it starts in the third quadrant, going to the first quadrant. Okay? Third quadrant, going to the first quadrant. If the degree of a polynomial function is odd and the leading coefficient is positive. Now, if the degree of a polynomial function is odd and this time it's negative, so the domain and range are the same. Set of real numbers. Okay, set of real numbers. So what would be your end behavior? When we say end behavior, the starting and then the ending point of your graph. So meaning, it starts with the second quadrant, going to the first quadrant. Second quadrant, going to the fourth quadrant. Okay? Second quadrant, going to the fourth quadrant. Okay? Second quadrant, going to the fourth quadrant. Or in short, left up, right down. Left up, right down. Okay? Again, the end behavior of a polynomial function with a degree which is odd and the leading coefficient is negative, the starting point will be the second quadrant going to the fourth quadrant. Okay? Second quadrant going to the fourth quadrant. So their domain and range, the same. Set of all real numbers. Okay? Set of all real numbers. Now, what about even? Okay? What about even? What if the degree, again when we say degree, you're referring to the highest exponent. So what if the degree is even? Okay? What if the degree is even? Then the leading coefficient is positive. So the domain still the same. Negative infinity to positive infinity. This time, to determine the range, we need to come up with the end behavior. Okay? So end behavior. So what is the starting and ending point of the graph if the degree is even and the leading coefficient is positive? Okay? It starts with the second quadrant and it ends to the first quadrant. So the graph is like this. Okay? So the graph is like this. If the degree is even and then the leading coefficient is positive, so the domain is the set of real numbers, so your end behavior will be both up. Okay? Both up. So starting point will be the second quadrant and then the ending point will be on the first quadrant. Now, what have you noticed? What have you noticed? There are two minimum value. Okay? So there are two minimum values. So we call it relative minimum and then this one is absolute minimum. Why is it? What's the difference of relative minimum and absolute minimum? What's the difference? Anybody? They are both minimum, but the other one is relative, and then the other is absolute. So what's the difference? Based on the graph. Anong difference? What do you mean by absolute minimum and then relative minimum? Anyone? What is absolute minimum? This one is absolute minimum, and then this one is relative minimum. What's the difference? Anyone? What's the difference? Anyone? What's the difference? What is absolute minimum and then relative minimum? They are both minimum points. But what do you mean by absolute minimum? Based on this graph. Ano yung absolute minimum based on this graph? What is the absolute minimum? So when we say absolute minimum, you're referring to what? Okay, very good. Okay, you're referring to the lowest value of y. Okay? So the lowest value of y. So therefore, what is your range based on this graph? What is your range based on this graph? What's your range based on this graph? What is your range? You do have absolute minimum, which is the lowest value of y. So therefore, what is the range? If your graph is like this, so what is the range? Anybody, what's the range? If your graph is like this, based on the graph, what is the range? Y is what? Is it greater than ba or less than equal? What is the range? What is the range based on this graph? What is the range based on this graph? So from the lowest value of y going to what? So from the lowest value of y going to where? From the lowest value of y going to people. From the lowest value of y going to where? Based on the graph. To determine the range. From the lowest value of y going to where? Going to positive infinity, going up. So that is positive infinity, meaning y must be greater than equal to the minimum value. Okay? Your minimum value or your lowest or your absolute minimum value. Okay? Y must be greater than equal to your absolute minimum value. When we say absolute minimum value, you are referring to the lowest value of Y. Okay? You're referring to the lowest value of Y. Can you hear me? Can you see me, people? Hello? Okay. Let's continue because you're not reacting. So let's continue. So that is if the degree is even and then the leading coefficient is positive. Okay? Now next, what about negative this time? Okay, negative. The degree is still even and then the leading coefficient is negative. So your domain is from negative infinity to positive infinity. Okay. What about the range? What about the range? So to determine the range, we need to come up with your end behavior. Okay. So again, what is end behavior? Referring to the starting and ending point of the graph. So degree is even and then the leading coefficient is negative. So it starts where? Third quadrant going to the fourth quadrant. Just like this. Okay. So like that. Now, you do have two maximum point. So this one we call it absolute maximum. And then this one is the relative maximum. Okay? So this one is relative, this one is maximum. So when we say absolute maximum, you're referring to the highest value of Y. Okay? The highest value of Y. So therefore, what is your range? So your range will be from the highest value of Y value. Okay? So that is in getting the range. So if the degree is even and then the leading coefficient is negative, so the domain still the same, negative infinity to positive infinity. But the range, how do you determine the range? You need to check the graph. Okay? How do we check the graph? You need to determine the end behavior, the starting and ending point of the graph. So if the degree is even, leading coefficient is negative, so the end behavior is from the third quadrant going to the fourth quadrant. Third going to fourth. Or in short, both, okay, both ends down. Okay, both ends down. Yung kanina, both ends up. Ngayon, down pareho. Okay? So that is the concept in determining domain and range of a polynomial function. Okay? So how do we apply that in a certain example? So I'll give you an example. So how do we graph and determine the domain and range of a polynomial function? Okay? So I'll give you example. Example number 1, f of x is equal to x cubed minus x squared minus 6x. Okay? F of x is equal to x cubed minus x squared minus 6x. First, okay, what is the degree? What's the degree? Okay, 3, the highest exponent. So 3. Now, leading coefficient. What's the leading coefficient? Okay, positive 1. So it's positive. Okay? So it's positive. Okay? So more or less, you can now determine the domain, right? So what's the domain? So the domain is from negative infinity to positive infinity. Okay? What about the range? Degree is odd. Okay? Which is 3. So what is the range? Degree odd, positive coefficient. So what is the range? The range is the same as, okay, the same as the domain. So you do have negative infinity to positive infinity. The question is, means how do we graph? Okay, how do we graph? So to graph that, so we have f of x is equal to x cubed minus x squared minus 6x. Okay? So first we need to solve it using the X Intercept. What is X Intercept, by the way? What is X Intercept? What is X Intercept? What is X Intercept? When we say X Intercept, you're referring to if y is 0, what is the value of x? If y is 0, what is the value of x? Or in short, find the zeros. Okay? Find the zeros of this function. When we say find the zeros, meaning you need to get the value of x. Okay? You need to get the value of x. So since f of x equals to y, so therefore, it's X intercept, so we can conclude that 0 is equal to x cubed minus x squared minus 6x. Or simply, x cubed minus x squared minus 6x equals 0. So they are the same. Okay, so same lang yan. Then what's next? What's next? You need to factor out this one. How do we get the factor? X cubed minus x squared minus 6x. How do we get the factor? How do we get the factor of this? Paano kunin yung factor? This one. Using factoring, how do we get the factor? X cubed minus x squared minus 6x is equal to 0. How do we get the factor? Okay. So the greatest common factor is x, so you need to put x outside. So that will become x squared minus x minus 6 equals 0. Am I right? X squared minus x minus 6, is it factorable? This one, is it factorable? X squared minus x minus 6, is it factorable? Is it factorable? X squared minus x minus 6, is it factorable? Yes, definitely it's factorable. So the factor of that one is x minus 3, x minus, x plus 2 equals 0. Okay? So x minus 3 and then x plus 2. Okay? Recall factoring. So x squared minus x minus 6, get the factor of that one. So you do have x minus 3 and then x plus 2. Now, find the zeros. How do we find the zeros? When we say find the zeros, meaning get the values of x. So equate each factor by 0. So we have x equals 0. That's the first factor. X minus 3 equals 0. And then x plus 2 equals 0. So you do have x equals 0, x equals 3, and then x equals negative 2. Okay? So you do have x equals 0, x equals 3, and then x equals negative 2. Now, what is the end behavior? What is the end behavior of this function? Degree is odd, obviously. Okay? Leading coefficient is positive. So what is the end behavior? What is the end behavior? Kapag add, tapos ang leading coefficient is positive, so what's the end behavior? Okay. So the first point will be on the third quadrant, and then the last point will be on the first quadrant. So like this. Okay? So the graph is like that. Okay? But how do you come up with that graph? So let's graph that. So how do we graph that? So we have x minus 3, x plus 2 equals 0. Okay? So first we need to plot the values of x. Ito muna, plot this. So you plot it. So we have 0. Then we have 1, 2, 3, this one. And then we have 1, 2, negative 2. So you have 0, 3, and then negative 2. Okay? Then what's next? Next is, find your y values. Okay? So how do you solve for y? How do you solve for y? Assign values of x. So how do we assign values of x? How do we assign values of x here? Of course, you need to assign values of x beside those we plotted numbers. Diba? Ito, -2. This one is 0. This one is 3. So you choose a number beside those numbers na pinlat natin a while ago. Okay? So let's say we have -3, -1, and then we have 1, 2. So what is the value of y? -3, -1, 1, 2. So what's the value of y? If x is -3, yung katabi ng -2, and then we have -1, okay? So -3, -1, and then we have 1, and then 2. So what will be the value of y? How do we solve for y? Substitute lang, here. So what's the value of y? If it's -3. Anong value ni y kapag -3 si x? What's the value of y? What's the value of y if it's -3? What's the value of y? Okay, 18. -18. Next. If it's -1, what is y? If it's -1, what is y? Okay, 6. Are you sure? Are you sure? Kapag -1, so we have -1 plus 1 minus 6 multiplied by -1. What's the answer? What's the answer? What's the answer? So we have 4. Okay? If x is 1, if x is 1, what's the value of y? Substitute lang. 1 raised to 3 minus 1 raised to 2 minus 6 multiplied by 1. What is the answer? What's the answer? What's the answer? Kapag 1, what's the answer? -6. Oh, next, this one. 2. 2. Okay, -8. Now, so we have this, right? Okay. So to graph a polynomial function, we need to determine its multiplicity. Okay. Miss, what do you mean by multiplicity? So when we say multiplicity, if the degree of each factor, so you're referring to the degree of each factor. Okay? You're referring to the degree of each factor. Okay? So what is the degree of x here? Anong degree ni x dito? Ito yung first factor. So this is your first factor, second factor, third factor. So what is the degree of the first factor? Exponent. What's the degree? Okay, 1. Next, what about here? Sa second factor, ano yung degree? Ano yung exponent nung buong factor? 1 also. What about the third factor? What is the degree? Okay, 1. Okay? So there's a condition. If the degree of the given factor is 1, okay, or 2, when we say 2, meaning even numbers. So if the degree is 1, you need to come up with straight line to your given points. Okay? Straight lines. So, ito si point, so straight line. Straight line. If the degree if the degree is even or more than 2, so kapag even, ito yung given na point, you need to put it something like this. Parang parabola. Okay? Parabola siya dun sa point. If the degree is odd numbers, pero 3, 5, 7, okay? So how do we plot the point? Or how do we draw it? So kailangan pa-curve. Pa-curve. Ibig sabihin, it will not touch the point. So sa labas ng point. So in here, if you have noticed that each factor has a degree 1. Okay? Ito degree nito 1, ito 1, 1. So how do we do that? So straight. Okay? Or cross the point. Cross the point. Yan, cross the point. Okay? Let's say yung degree nito ay 2. So x minus 3 raised to 2. So your x equals 3. So therefore, it's not cross. Yung point na 3. It should be what? Curve. Bound. Okay? Hindi siya straight. Bound siya dun sa point. But since the degree is odd, and particularly which is 1, so cross the point lang. Okay, cross the point. Now, according to the end behavior, it starts with the third quadrant and end with the first quadrant. Okay? Start with the third quadrant and then end on the first quadrant. Okay? And then we need to plot the other points. So the first one is negative 1, 4. So we have 1, 2, 3, 4. Okay. Next is 1, 6. So 1, 2, 3, 4, 5, 6. So here. And then we have 2, 8. 6, 7, 8. Okay. So from here, yeah. So it will not touch this point. Straight lang siya. Okay, straight to that point. So that is the graph. Okay? So hindi siya bound. It's not curved. So straight lang. Okay? So that is the graph of x cubed minus x squared minus 6x. So from here, you can now identify the range. So the range will be from negative infinity to positive infinity. Kasi pwede mag-extend eh. Yung y value going to positive infinity and then going to the negative infinity. Okay? So that is the graph of a polynomial function. Okay? In here, this is your relative maximum. And then this is your relative minimum. So in here, what is your relative maximum? What is your relative maximum? When we say relative maximum, you're referring to y value. Ano ba yung y? Ano yung y value neto? Okay, 4. So that is your relative maximum. Okay? And this, where's the absolute maximum? Do we have a absolute maximum here? Okay, why? Why? Why is it? Bakit walang absolute? Higher than? Okay, higher than 4. Okay? Okay, there's no other point which is higher than your relative maximum. Nag-iisa lang eh. Okay, nag-iisa lang. What about your relative minimum? Okay, negative 8. Okay, so negative 8. So that is polynomial function. Okay, so that's polynomial function. Okay, another example. Let's say the given is y equals to negative x squared, x plus 1, x minus 3. Okay. What about this one? So negative x squared, x plus 1, x minus 3. If you have noticed, the given function is written as factors. Okay? Naka-factor siya, di ba? in our first example, naka-polynomial function siya. In here, what have you noticed? Naka-factor out na. Okay? You do have, how many factors do you have? This is your first factor, second factor, and then third factor. Now, so since it was written as factors, okay, naka-factors na, what is your highest degree? It's the highest degree. Naka-factor out, naka-factors na siya. Meaning it's not a polynomial function. The given expression is factors. So to determine the degree or the highest degree, you just simply add each degree of each factor. Okay? Add each degree ng factors. Kasi naka-factors sila eh. Hindi yung first example natin, it's a polynomial function, di ba? It's already polynomial function, you need to factor it. This time, naka-factor out na sila. Okay? So how do we determine the degree of a polynomial function? Just add. So 2 plus 1. What's the answer? 2 plus 1 plus 3. How many? Okay, 6. So meaning, degree is 6, so that is even. Okay? Even. Now, what is your leading coefficient? What's the leading coefficient? Ano yung leading coefficient? Based on this, what's the leading coefficient? Leading coefficient. Coefficient. Okay, negative. So it's negative. Okay? So even, the degree is even, and then the leading coefficient is negative. Okay? Degree is even, and then the leading coefficient is negative. What is the domain? Leading coefficient is negative, the degree is even. What's the domain? Okay, negative infinity to positive infinity. Okay? No question asked. Okay? Negative infinity to positive infinity. Now, next, what is your end behavior? The graph looks like what? What's your end behavior? Both ends up or both ends down? Okay. So, what's the starting point? Where? Okay, third quadrant. And then the ending point is? Okay, fourth quadrant. Okay? Degree is even, and then the leading coefficient is negative, so the end behavior is, the starting point is on the third quadrant, going to the fourth quadrant. Okay? So we cannot predict the range. We need to graph it before we find the range. Okay? So how do we graph this one? First, we need to find the values of what? Of x. Okay? So we have x squared, x plus 1, x minus 3 equals 0. So solve for x. So x squared equals to 0. Equate each factor by 0. So x plus 1 equals 0. And then x minus 3 equals 0. So what's the first factor? What's the first value? Ano yung first value? Okay, 0. Next. What about the second value? Okay, negative 1. Next, the third value. Okay, positive 3. So we need to plot this one. 0, negative 1, and then positive 3. Okay, try to remember that one. So 0, 1, 0, negative 1, and then positive 3. Okay. So here we go. So we have 0, and then we have negative 1, ito yun, so negative 1, and then we have positive 3, 1, 2, 3. Okay. See? Okay. So what will be your multiplicity? In here, what is the multiplicity? When we say multiplicity, referring to the degree of each factor. So in here, what is the multiplicity? 2. Okay. Here, what is the multiplicity? 1. Okay. Here, what's the degree of, what is the multiplicity? Okay, 3. Okay? Again, when we say multiplicity, you're referring to the degree, okay, degree, exponent of each factor. Okay, exponent or degree of each factor. So here is 2, this one is 1, and then this one is 3. Now, okay, let's proceed now. So if the multiplicity is 2, okay, if the multiplicity is 2, is it straight? Or is it across the point? Or bound the point? This one. So yung x niya is 0. This one. Is it bound, cross, or outside the point? Or curve along the point? Okay, bound. Okay, bound. Okay, parang parabola thing. Next, this one. This one is, the multiplicity is 1, so that is across. Okay, across. Across the point. Okay. And then this one is 3, curve. Okay. So curve. Meaning, outside the point lang. Okay, outside the point. Okay, outside the point. But the end behavior of this one is, from the 3rd quadrant, going to the 4th quadrant. Okay? 3rd to 4th quadrant. Now, what will be the graph? So the graph is like this. Okay? So, pa-curve dun sa 3. So that will be the graph of this polynomial function. Okay? So this is the graph of a polynomial function. So you do have absolute maximum. So that's your absolute maximum. And then this is your relative maximum. Again, when we say absolute maximum, you're referring to the highest value of y. Okay, so that's the graph of a polynomial function. Okay? Okay. So that's it. That's a polynomial function. Okay? So any more question, people? So try to remember the conditions, yung multiplicity and behavior, and then the degree, and then the leading coefficient. Okay? Because the range will be based on your graph. Okay? On your graph. If there's an absolute maximum, so you need to identify the y value there, going to the negative infinity. Okay? So that is a polynomial function.